The James Webb Space Telescope has found something terrifying while observing ancient galaxies in the early universe. It was studying some of the oldest galaxies ever discovered, galaxies that formed just a few 100 million years after the universe was born. To put that into perspective, if all of human history were a book, these galaxies would exist billions of years before the first page was ever written. And this is where the story turns into a paradox. Hidden inside these galaxies are gigantic black holes with a mass so absurd that it doesn't fit the age of the universe or the amount of matter available at the time. Based on everything we know about how black holes grow, they simply shouldn't be there. And yet, there they are. So, what are we missing? To understand why this is such a problem, you first need to know how black holes normally form. Most black holes are born when a massive star reaches the end of its life and collapses under its own gravity. That's only the beginning. After they form, they start growing. They absorb gas, dust, stars, and sometimes even other black holes, but that growth takes time. A lot of time, millions or even billions of years. Yet James Webb is finding black holes with millions or even billions of times the mass of our Sun at a time when the universe was still incredibly young. And that's the contradiction. These objects appear far too early. There simply shouldn't have been enough time for them to grow this large. And the mystery gets even deeper. In many cases, there doesn't seem to be enough surrounding matter to explain where all that mass came from in the first place. And this is where things start to get really strange. There is one possibility that could explain all of this. What if some black holes were never small? What if they were born enormous from the very beginning? The idea sounds absurd, but some scientists think that in the earliest stages of the universe, massive clouds of gas may have collapsed directly under their own gravity, without forming stars, without going through the stages we normally expect, simply collapsing into gigantic black holes. If that happened, it would solve one of the biggest problems behind this discovery. They wouldn't need billions of years to grow. They would have been born as monsters. But there's a problem. Until recently, this idea was little more than a hypothesis. We had no evidence that anything like this had actually happened. And this is where the numbers start becoming difficult to believe. We're not talking about black holes that are slightly larger than expected. Some of the objects James Webb has found contain millions or even billions of times the mass of our Sun. And remember something. We're seeing them at a time when the universe had only just begun. It's like finding a century-old tree growing in a field where the seeds were planted only a few months ago. It simply doesn't fit. The more astronomers study these primitive galaxies, the more examples they find. And that raises an uncomfortable question. Are we looking at an incredibly rare exception? Or is our understanding of how black holes are born incomplete? And that's when James Webb found something particularly strange. While studying some of these primitive galaxies, astronomers detected signals that seemed to match an idea that had been debated for years. The possibility that certain black holes were never born from stars. Instead, they may have formed directly from enormous clouds of gas. That might not sound important at first, but it would completely change the story. If a gigantic cloud of gas collapses directly, the resulting black hole can begin its life far more massive than normal. Suddenly, the time problem starts to disappear. It wouldn't need billions of years to grow. It could have been born large from the very beginning. And that's what makes this discovery so interesting. For the first time, astronomers believe they may be looking at something that resembles one of these candidates. But even if this idea is correct, there's still a problem. Seeing a black hole is impossible. They don't emit light. They don't shine. And when they're billions of light years away, the challenge becomes even greater. So how do astronomers know they're there? The answer is that they don't observe the black hole directly. They observe what happens around it. When enormous amounts of gas fall toward one of these monsters, the material heats up to extreme temperatures. And before disappearing, it starts releasing huge amounts of energy. It's like trying to find an invisible object by watching the chaos it creates around it. And that's exactly where James Webb started finding something unexpected. What caught the attention of astronomers wasn't just the presence of these black holes. It was where they appeared. Some were hidden inside galaxies so young that, in theory, they shouldn't even have had time to develop complex structures. And yet, there they were. They didn't look like objects in the middle of growing. They looked like objects that had already completed most of the journey. It's like walking into a city that was built yesterday and finding fully completed skyscrapers on day one. Something doesn't fit. The more observations arrived, the harder it became to ignore the problem. Because this was no longer a single strange case. Too many examples were starting to appear. And when an anomaly stops being unique, scientists have to consider an uncomfortable possibility. Maybe the mistake isn't in the observations. Maybe it's in our understanding of the early universe. And that leads us to a fascinating possibility. What if the first generations of stars were very different from the ones we see today? The early universe was a strange place. There were no planets. There were no heavy elements. And conditions were so different that some of those first stars may have reached unimaginable sizes, far larger than any star we observe today. If one of them collapsed, the resulting black hole wouldn't be ordinary either. It would be born with a huge advantage. But even that may not be enough to explain some of the objects found by James Webb. And that's where the direct collapse idea comes back into the picture. Because the more massive these black holes appear to be, the harder it becomes to explain them through traditional mechanisms. And this is where the story becomes truly interesting. Among the galaxies observed by James Webb, astronomers found several objects that seem to be in a very unusual state. Too bright to be simple clouds of gas. Yet also too peculiar to fit what we would normally expect from a young galaxy. It was as if they were observing something in the middle of a transformation. Something that wasn't yet a fully developed black hole, but didn't seem to be a star either. That immediately caught their attention. For years, theoretical models had predicted that a direct collapse could leave behind signatures like these. Not definitive proof, but exactly the kind of object astronomers had been trying to find for decades. And if that interpretation is correct, we may be looking at something extraordinary. Not the final result, but one of the earliest stages in the birth of a supermassive black hole. But there's something important you should keep in mind. James Webb hasn't solved the mystery. Not yet. What it has found are clues. Clues that seem to point in a very specific direction. The problem is that the early universe is so far away that every observation is like trying to reconstruct a story from a handful of blurry photographs. For now, several explanations remain possible. Maybe some black holes were born much larger than we imagine. Maybe they grew in ways we still don't understand. Or maybe there's something fundamental about the early universe that we're missing. And that's why this discovery has attracted so much attention. Because it doesn't answer a question. It creates a new one. If these objects really existed when the universe was just beginning, how many other things do we think we understand that might actually be wrong?